but I see you also can see the title, which is relatively long. So let me, and even more I might say complicated, so let me explain what is the motivation behind our research. So our starting point is the idea that countries with highly synchronized business cycles can effectively form monetary unions. Because in case of those countries, if one common central bank is able to design one optimal monetary policy for all the countries. And this motivated very big branch of the literature that focuses on measurement of business cycle synchronization. However, even up till this point, it's mostly done with correlations, which have been heavily criticized over the years. And of course, as a response, there came alternatives. And one of those alternatives that became extremely popular were dynamic factor models, and especially the version of Cosette and others, and with original paper by Otrok and Whiteman, because they solved the problem of big N and small t, which actually is not allowing to estimate those models in certain circumstances. So this research actually, so dynamic factor models became a standard in this literature. However, their usage has been very similar. First of all the papers use macroeconomic data, which is, of course, very understandable because we are trying to assess synchronicity between two economies. The second thing that we can find from the literature is that when authors in European context, especially in the context of Euro area, apply models with just one factor, well, they get the result that business cycle synchronization in European Union is relatively high. Now, models with more, let's just say, more elaborate factor structures, however, still are mostly done on macroeconomic data. They just introduce, for example, different groupings, because you can have a factor that is common to every country and every time series, or they can be grouped, for example, under European Union, NAFTA, and other organizations. So this is like the state of this macroeconomic assessment of business cycle synchronization using dynamic factor models. And the things started changing a little bit since the seminal works of Acemoglu and others in Gebet, who actually tried to look for granular sources of business cycles. So what they did, they actually started using company level data. And a little bit later, Di Giovanni and others even made a paper using the same approach for international business cycles. And of course, we would like to do exactly the same thing. However, we do not possess detailed data on companies for the entire Eurozone. So we decided to do the next best thing. And the next best thing is to go at least a little deeper. And there are two ways in which you can go deeper. First way, you can go from macroeconomics, so from the country level, you can go to regional perspective. Here again, there's been some work done on business cycle synchronization. However, most of the work is just simple correlations based measures. There are only two papers that used DFMs in this context. One is for Chinese provinces and one is for Eurozone. And the second perspective that we can have is sectoral. So now we could divide economy not into regions, but we could divide economy into sectors. And again, there's been very, very little research done, and there are only 3 papers that actually apply DFMs in those cases. And as you can see, I'm the author of the 2, and my co-author is the author of the other 2, so we kind of monopolized this very tiny niche of the market. However, as you can see, that wasn't enough for us. We still wanted more, so we decided that we were gonna combine those. And we're gonna use both regional and sectoral perspective at the same time. And the only reason we could do is that because since recently there is new data available. So what is the data that we collected? We collected the data on time series of real gross value added at annual frequency for the period 1980 to 2019 for 10 European Union countries. Then, within this data set, we have division of the data into 6 different sectors, and from the other perspective, countries are divided into 54 different NUTS1 regions. Of course, each country has a different number of regions, which actually is not a problem here because we deal with growth rates. Data comes from Eurostat, and before the estimation, data was logarithmized, first differentiated, and diminished. And look, I understand that me just telling you that is not very helpful in understanding our data set. So let me give you a sketch of our data structure. So our data looks like this. Europe, in our example, is made out of 2 countries, right? Now, each of these countries is divided into 2 regions, and then each of these regions is divided into 2 sectors. Of course, we have 6 sectors, 54 regions, and 10 countries, but this is the data structure. This is the data structure that we have. So here, we would, in this hypothetical case, we would have 8 different time series. Now, this data structure is allowing us to estimate a very specific case of dynamic factor model. And before I go into interesting part of the model, I'm going to go through the boring stuff that needs to be said every time. So, first equation we see over here is this. It is called the equation for observable variable, and it tells us that gross value. Of course, here we talked about growth, the mean growth rate, but growth value added in growth rate of growth value added in country I, in sector J, and in region K is driven by 4 different factors. One is called European factor, one is called country factor, one is called sectoral factor, and one is called regional factor. Then we have the residual component that we call idiosyncratic term. Of course, as it's usual with the dynamic factor analysis, we are assuming that each of the factors, as well as idiosyncratic component, is driven by the autoregression. In our case, L is equal to 3, so we allow transmission of the shocks through 3 periods ahead. And of course, we have classical assumptions about the nature of innovation, so they come from natural distributions with constant variances. Now, the only one remaining issue in terms of assumptions is that we need to simply assume that idiosyncratic terms are uncorrelated at all leads and lags. Okay, and what this leaves us with is betas. Look, the betas that you see over here are called factor loadings. Why do we have them? Because you can imagine that if there is a given shock or a factor, it can be felt differently by a different country. You can even imagine that some shock that is positive for one country might be negative for the other. And this is why we are allowing for the transmission of the shocks, of the factors to growth rates of gross value added through those factor loadings. And now the most important thing. So what are the factors that we are examining? And look, as it turns out, in case of our data set, definitions of factor are simply dictated by data structure. Let me explain what I mean by that. Look, European factor, in our case, is a factor that is common to all time series under scrutiny, right? So this is common to every country, every region, and every sector. Then we can define country factor. Country factor is a factor that is common to all time series within one country, and similarly, regional factor is a factor that is common to all time series within a region. And those three are very, let's just say, easy to understand. Then we get the fourth possibility, and those will be sectoral factors. So sectoral factor is a factor that is common to all time series belonging to the same sector regardless of what region or country they come from. So again, you can see one more time that over here we got three types of factors. International is this one and this one, right? Because here, this one we can call international because it's common for everyone, and here, because it's common for one sector regardless of the country of origin. Then over here, we could say we have national factor, right? Because this is what happens at the country level. And here, we got intra-national factor because it tells us what is happening and what is happening below the country level. Okay, so carrying on with more boring stuff. So this is typical model that suffer from rotational indeterminacy, which means that, we cannot pin down signs and scales of factors at the same time. So in order to do so, we make very simple assumptions that do not have actually impact on our results later on, which is, however, we need to choose some regions as base to identify size. And let me just give you an example of European factor. We are simply assuming that European factor is positive for industry in Hessen, which is the biggest region in Germany in terms of GDP under our scrutiny. And we do very similar for regional country European country sectoral and regional factor. And then to pin down the scale, this is actually even easier. We simply assume that variances of innovations are constant. Then, as this is a Bayesian procedure, we have certain amount. We need to have some priors. In our case, priors are very uninformative. We assume nothing at the beginning, although we change the priors in various ways, and this has almost no impact on the result. So, on factor loadings, this is normal, with 0 mean and 1 standard deviation. On variance innovations, it's inverted gamma. And only in the case of autoregressive polynomials, this prior, as you can see here, the terms for standard deviation is simply shrinking with each next lag. It simply means that we are more sure, we are less sure that the first lag is 0. We are twice as sure that the lag is 0, another lag is 0, and we are again 1/2 as sure that another lag is 0. Again, if we change it even quite substantially, we get very similar results to what's going to be presented here. Yes?
Can you go? You said. Can I interrupt you? Maybe it's better. Okay.
Go.
Just one thing. You say that if you change the prior, the results are robust.
Yep.
Okay. And as from a Bayesian point of view, why you do this? Because basically, if you insert a prior, you are sure about you want to, how can I say, add something to the model. So you have a prior, you have a belief.
But as you can see here, I'm doing the opposite. Look, I'm using uninformative priors. Those are priors that basically are trying to say, I know very little about it, and I don't want to guess too much. And look, I believe that this is a very good idea in this case, because when you have dynamic factor models, and we know that dynamic factors do not exist in the real life, then asserting our ignorance through prior is a very good choice. Okay, but we can talk about it a little bit more later. Let me just
Thank you for your answer.
No. Okay, now the model is this model cannot be estimated normally, so we actually need to do it through Bayesian procedure, and we are using a Gibbs sampling which is Markov chain Monte Carlo method of approximating joint and marginal distribution by sampling from conditional distributions. So we do it like this. First, we have some draw of factors, and conditional on this draw, we estimate, we simulate AR coefficients and variances to innovations. Then we repeat. Based on these factors, we draw factor loadings, and once we have factor loadings and once we have AR coefficient and variance innovations, we are drawing. We simulate the factors. The results I'm presenting here are when we repeated it 200,000 times with 20,000 burn-ins. However, we get the same results even with like 1,000 iterations. And finally, the main tool of our analysis is variance decomposition. So what we're going to try to do is that we're going to divide variance of growth rates of gross value added into share that is associated with European, country, sectoral, and regional factor, and of course the residual component, which is idiosyncratic component. However, before I get into the results, let me just give you one more information. Because look, in this setting, we have 324 time series and 71 factors. So, in order to present the result, we needed to make some averaging at the country level, at the regional level, and at sectoral level. So look, basically it works like this, that if I want to calculate variance decomposition for country 1, I simply use those as shares. So I use each individual time series values as shares in the full country gross value added, and this is how we calculate it, right? We can do the same thing from country perspective, sectoral and regional. However, in this, over here, I'm going to only present results for countries and sectors because otherwise I wouldn't be able to fit them on the presentation. Okay, so let's go first to the results. Now, look, first test of a dynamic factor model is whether it can replicate reality. And this is what we get. This is the European factor that we had, and we can actually see that it matches up with some of the stylized factors, some of the real historical events, like Volcker disinflation, ERM crisis, dot-com bubble, first bubble that burst. We've got 2008 financial crisis, and we have sovereign debt crisis. Now, before I go further, I want to say that we actually did not only what we said, what I explained, but we also did 2 additional exercises. In one of these exercises, we took disaggregated data and we estimated one factor model. And in the second exercise, we took the data, we aggregated to country level, and we also calculated one factor model. And now,
sorry, just to get the intuition of that.
Yeah?
I mean, is this basically a hierarchical model, right?
this is not a hierarchical model. This is no. But you have one. Look, it has a hint of this hierarchical introduction through weights.
Okay.
Yeah, but this model is based on growth rates. So all the time series are on equal footings. So in this case, there are no hierarchy imposed by us. And all the factors are drawn at the same loop. As there's this 6. Okay, again, a little bit later I can provide you with more detail. Okay, and look, why did we did this exercise with instead of just doing our model, we did the other 2 because we wanted to explain one possibility why we get such a good results for European countries when we use one factor models for macroeconomic data. And look, when we aggregated data on average, we see that European factor is accounting for 66% of the variance in gross value added in Europe. When we did exactly the same thing, but we used disaggregated data, as you can see, the share of variance explained by European factor is below 26%. And then when we use full 4-factor model, then we found out that it has fallen even further to 8.5. And look, this is not only the result of the data, because we did one more thing. We actually generated the data from 4-factor model, and we so in a simulation with various parameters, we tried it many times with different values. We got the same result, and this result was very similar to what you see over here. Both of these steps, so using not enough factors and aggregation of the data, simply led to the overestimation of the variance share attributable to European factor. And look, our results are showing actually that on average, each of these factors is important, and we should look more closely maybe at the revolution. However, this analysis has been done over a relatively long period of 39 years, so more interesting developments are when we look into subsamples. Oh, I'm sorry, before that, we can also look at the results from the sectoral perspective. So here we have, so what we can see over here is that most internationally integrated sector is industry. It's mostly driven by manufacturing, but this we got actually from our different paper. And as you can see, because this is actually a very important result, it is sectoral factor, not the European factor, that is main driver of the European business cycles. You see, actually here the part of variance explained by this factor is way bigger. Okay, but let's look at what we have when we move from one to the other subsample. And look, what we observe is a great convergence. Because what has happened? Look, the relative role of country factor has decreased very sharply. And look, this decrease is mostly associated with the rise in sectoral factor, not the purely European factor, right? So we actually can see that the progress that was made in terms of business cycle synchronization actually came from tighter sectoral ties. So we could actually, again, this is not from this paper, but in other paper we are actually shown that this is the result of tighter integration into global value chains, European value chains in this context. Okay, and again we see exactly the same pattern from sectoral perspective. Here we can actually see how industry have evolved from sectoral share of 22 to 50, and of course, as we would suspect, financial services, and those non-financial services are business services here. So actually, those are the other two where we observed the highest increase in the role in this international part of the movement that we try to explain. Okay, so let me conclude. I do not have my phone. Like, do I have? How much time do I have? I'm sorry.
25 minutes.
No,
you. Sorry.
Yeah. Okay. Yeah.
Just-
I understand. Okay. So
You
what
don't
are
have-
our main results? First, aggregation and usage of the models with not enough factors will definitely lead to overestimation of the role of the common factor in driving GDP or gross value added as a whole. I'm sorry. Let me get here. So now we find out that European factor actually is not the one that drives the movement. Actually, what we find out is that sectoral factor is the one that explains nearly 70% of business cycle movement in Europe, as opposed to the European factor that takes only 30. Now, we find out that industry and financial services are the most international carriers, the main carriers of international business cycles. And finally, what we get is that our results are showing strong support for European Commission view on the business cycle synchronization in Europe, in general. So basically we see that the countries converged, and this convergence was done through decrease in the country factor, share, and increase in the sectoral factors. And finally, so what are the consequences for the countries that are either in euro area or are expecting to join? And what I would like you to now look at are the results for these are the results for the last period. I'm just repeating them. We already seen them. However, as you might notice, I actually grouped those factors a little bit differently. So look, here we see that actually international factor, like purely international factor, purely European factor, is is around 16%, right? So if those countries, like 9 of them actually have common central bank, we can see that maybe this central bank is not really well equipped to conduct one optimal monetary policy. Why? Because of course the share of variance here is relatively tiny, right? And we can also say that even though we've got big portion of international variation explained by sectoral factors, well, sectoral factor, we've got 6 sectors in our model alone. So even this would make job of a European central bank a little bit more complex. And you could look at these results as a very pessimistic view. However, this is not what we do. We actually see this as a very positive view for the euro area. And why is that? Because what national central banks can actually control? They can target national component. And we see that national component is actually has the lowest share, only 6.2%. Well, what does the government cannot control within a country? What happens in regions and what happens in individual time series, because this is also idiosyncratic component. So look, what our results, what results of our exercise are showing is that the cost of losing independent monetary policy might be overestimated. Why is that? Because we are usually assuming with macroeconomic analysis that countries are homogeneous entities. And as our results are showing, they are not. And if your country is not a homogeneous entity to begin with, you cannot say that the monetary policy conducted at national level is optimal from the perspective of every sector and every region. So in this case, we might say that the costs of joining euro area are a little bit overestimated. I hope I'm in time. Thank you very much.
Thank you.
And if anybody has a question, I will be more than glad to answer.